In 2017, the World Health Organization estimated that about 35 to 40 million people have lost arms or legs. Imagine losing a limb and regaining not just function, but control, precision, and even sensation. Welcome to the amazing world of prosthetics, where engineering meets humanity. This is where mechanical and biomedical engineering are blended with the humanities.
Mechanical prosthetics are marvels of design. They used advanced materials like carbon fiber and titanium for strength and flexibility. Mechanical engineers play an important role in the blueprint for the prosthetics. The human body is composed of different body parts that have different functions, meaning there are a variety of prosthetics which must be constructed.
Some examples are lower limb prosthetics, which replace missing legs, upper limb prosthetics, which replace missing arms, bionic limbs, which offer a more fluid range of motion, and osseointegration, which enhances stability and functionality.
And the biomechanics are just as impressive. Biomedical engineers strive to create a link between human and machine. They combine design, material science, and medical knowledge to improve the day-to-day lives of its users. This includes the addition of actuation systems like motors and pneumatics that allow movement that mimics natural limbs. Fabrication techniques, including 3D printing, are making custom prosthetics more accessible than ever.
But it's not just about mechanics. Prosthetics are actually a specialized branch of medicine that is dedicated to the design, development, and fitting of artificial devices. They help individuals who have lost their limbs due to congenital disabilities, trauma, or medical conditions. Comfort and fit are critical. Poorly fitted prosthetics can cause pain, skin damage, and even rejection. Some prosthetics are easy to place, such as legs, which can be slipped on off, whereas some must be surgically installed.
For example, pacemakers are prosthetic devices that take over the function of the heart's natural pacemaker by generating electrical pulses to ensure a regular heartbeat. A cardiologist will insert the pacemaker by making a small incision in the upper chest and threading wires through the blood vessels and then placing a pulse generator under the skin and connecting it to the leads.
Not only do medical teams insert the devices using years of training and schooling, medical teams also work closely with engineers to design sockets that distribute pressure evenly and to make sure the prosthetics are as similar as they can be to their organic counterparts in terms of physical appearance and functions. Rehabilitation engineering ensures patients adapt safely and effectively while restoring their life quality. It isn't purely technical. It is something that can be life-changing to a lot of people. In a survey that consists of persons aged 18 to 84 years identified from the Amputee Coalition of America registry as having a major upper or lower limb loss due to a vascular disease, trauma, or malignancy, 75.7% appear to be satisfied with the overall performance of their prosthesis.
The accessibility of mechanical prosthetics is important to consider. Mechanical prosthetics can range from $3,000 to $100,000. Insurance is also an additional cost on top of the prosthetics. It can be difficult for individuals to afford mechanical prosthetics, and they are only getting increasingly expensive as engineering and technology advances. In addition, there are many global disparities that create concerns for prosthetics in poorer regions.
Patient rights are also important to consider. Patients must be informed of all the positive and negative aspects of prosthetics. In fact, they have a right to choose what technology they would like, and there is often concern that there is overtrust in technology.
In fact, the designers must also be able to balance the need for increasing the technology and the cost of their prosthetics. It can be seen as unethical to provide a product that is inaccessible for its consumers. In addition, in recent years, prosthetics have been shifted towards aesthetics rather than their functional design, which is creating lots of debate.
Yes, one of our main missions is to make our innovation as accessible to all incomes as possible, while still maintaining our prestigious design and quality, so we avoid widening health gaps and support real equality in care.
Mechanical prosthetics are more than machines. They're lifelines.
They restore independence.
They push the boundaries of engineering.
And they challenge us to think ethically.
This is the future of prosthetics, and it's already here.